warahmatullahi wabarakatuh, and a very good evening to our lecturer, Dr. Hawati, and also Encik Hafiz. So today we are going to present to you our last mini project of integrated circuit design. Next, so here's are the team members for group 17. My name is Aina Zaki Najla binti Zainal, and my matric numbers is 2210323330. And my team members is Aini Nasya binti Kamar Zaman, Muhammad Nakib Fahim bin Muhammad Syahid, Nur Saila binti Bahari Muddin, Muhammad Nur Syarul Nizam bin Muhammad Nurisan, and also Lokman Najmuddin bin Muhammad Alwi. Mind you that we are not for introduction, this mini project consists a lot of steps which are required to be done by week. So next slide will be shown the next step by step that we had done throughout the weeks. So these are the contents of our mini project. Mind you that we are not segregate our part, as each of our team members are done the same process. However, to make it our discussion going smooth and to save our times, I will start with the simulation waveform and analysis and proceed with the layout design and also LVS and DRC. So first is the Boolean equation. So here's are the Boolean equation that we have created. So we use n bar plus q bar plus b and equal to y. N bar, q bar, and b is our input, and y is our output. So these are the truth table from the equation that we have created, which consists the three inputs. As you can see, the NQB is our output, is our input, and y is our output. That's it. As for schematic, we use mental graphic to design the schematic circuit. So as you can see, from the top part, it is the PMOS, while the bottom part, we call it as NMOS.
Thank you, Aina Zaki. My name is Aina Siha binti Kamal Zaman, and I will explain my part, which is test bench and waveform. After finish schematic, we move to test bench. We create the test bench by fill in the unit path and PWL into the input to get the output. Then we can run the waveform. Next. Okay. After run, we will get the output waveform. We can check if the waveform is true or not by compare with the two table. When the outcome is show the same result with the two table, so our waveform is correct. That's all from me. Thank you.
Thank you, Aidin Nasiha. My name is Nur Sohaila. So I'm going to explain layout design. After we finish a simulation of waveform, firstly, a transistor level. The transistor level display the transistor gate signal and QB for identification. Y is the output level. Pull-out network show a transistor NQB down to the output. Pull-down network side show directional of NQB and NQB transistor side. Next. Okay. Then we proceed to Euler path. For pull-out network, M prime to Q prime to B and to the output Y. For pull-down network direction from M prime to Q prime to B to ground. That's all for my part. Thank you.
Alright, thank you. My name is Muhammad Nakib Fahim Muhammad Syahid. And then I will be explaining about the stick diagram. Alright, the stick diagram, we're using the we sketch the stick diagram by using the Euler path. And then we can see that this is a stick diagram we have. And then we the middle of the connection is inverter. And then we use the metal too. Because we can overlap the another metal and poly, right? Okay. Next is a layout. The layout of the design mask is determined by a set of geometrical requirement in the layout display, and stick diagram are used for the layout, which state the contact metal, polysilicon, L1, and P1. This is our layout schematic, and then we assume that the 1 cube equal to 1 lambda to get the accurate schematic layout. This is our layout from the VMware application. Alright, that is same thing. Right, that's for my part. Okay.
Okay, thank you, Rakib. My name is Manusharul Nizam. I will to talk about the DRC, and the LPS will continue by Lokman. Okay, the DRC. Next slide. Okay, the DRC to verify whether our specific design meets the constraint imposed by the process technology. What the DRC function? Okay, the DRC function to check the minimum weight, minimum spacing, area, weight metal, missing line, via wire, spacing node, spacing, and ends of the line spacing. So that the DRC error. My team have two DRC error. First, we cannot run the DRC because lesion issue. We run the DRC not in the lab session. Okay. After that, the overlap of metal one. All right, that's all for me. Thank you.
Okay, thank you, Syarul. My name is Loman Najimuddin. So for my part is LBS. That means layout versus schematic. The draw shape of the layout, which stand in for the electrical component of the circuit at their connection, are recognized by LBS verification software. This LBS software will be compared the netlist to the other netlist which are related. So we get the successfully LBS. This is for LBS error. This happened because we were using the wrong material for labeling input port and on layout. So we go to the lastly for the conclusion. To the sum of the result, there are several ways to create an integrated circuit. This method is essential for creating error-free layout. Circuits are also compared to valid specific design. In the end, we managed to successfully implement this project. So thank you very much.
Terima kasih semua. Thank you for all participate.
Thank you
For
everyone.
our commitment.